And speaking of taking advantage of the opportunity of bringing innovation to market and harnessing the power of innovation and creativity and entrepreneurship, it's my great honor now to introduce our next speaker. It's my pleasure to introduce Dr. Vicky Sharpe, who is the President and CEO of Sustainable Development Technology Canada, a Government of Canada initiative whose mission is to build a sustainable development technology infrastructure in Canada. Dr. Sharpe brings over 25 years' experience in the energy industry, from exploration and production through generation and distribution to end use. Prior to joining SDTC, Dr. Sharpe was president of GRI Canada and Astral Group, where she demonstrated leadership and vision in the use of innovative technologies across Canada's primary economic sectors. Previously, she held the role of Vice President of Ontario Hydro International, Inc., where she created new global revenue streams for environmental and energy utilization practices. And so it is my great pleasure to introduce a partner in the quest for innovation and development of new technologies, Dr. Vicky Sharpe. Dr. Sharpe?
Thank you very much, Paul. That was a very nice introduction, and I am delighted to be able to talk to you today. I have a really rampant cold, so I hope I can be able to keep talking. Usually it's not a problem, but I am here because we really believe passionately in the capability of researchers and Canadians to be able to contribute strongly to this partnership. I think clean tech is part of the way forward. As you look at some of the debates and the way that people will make investments in the future of our economies, we need to keep very much firmly in mind that if we do not take this opportunity to retool Canada and to take on a greener approach as we begin to make investments in that infrastructure, it will be an opportunity that is horribly lost. And I believe that we have people in this room today who will be able to make sure that we don't miss the opportunity and that we do really well. So what I want to do is to talk about a number of things. Obviously, clean tech is a phrase that has different interpretations from different people. I'll talk about that. The Canadian clean tech landscape and innovation here, the critical component of how we finance it, the importance of the partnership that we've been exploring today and this afternoon, and obviously some summarizing remarks. Essentially, clean tech is a very broad range of opportunities. And what it does, in essence, is that you get a simultaneous reduction in financial and environmental costs at the same time as you are driving better performance. So if you look at the definition of sustainable development, which is economy, environment, and society, you have elements of those which are going to be delivered in an improved fashion. And therefore you can see why clean technologies are essentially the primary drivers behind the emerging carbon market as we move from our traditional carbon-intensive society to one that is less so. But also as we actually do that, we will see greater sustainability because these technologies are an enabler to a much more reasonable and sustainable future. I'm going to give you just a couple of examples of what that might look like. Lighter, smaller, and stronger is our features or characteristics of clean technologies. The one we've got here is called WindSmart. It is a technology that essentially has a hydrostatic drive so that you are not taking your gearbox up into the nacelle of a wind turbine, and therefore you are making that nacelle lighter. It is more easy to erect the towers because you don't have to worry about the weight feature. You have a lot of cost and maintenance issues with gearbox failures in wind turbines. And this technology will take essentially through hydrostatic pressure the energy and put it straight into the grid system. So what you have is a technology that is delivering all of these benefits and at the same time obviously improving the likelihood and uptake of a renewable energy. I'll take the example of Vaperma around something that's less expensive to manufacture and operate. We've seen a lot of focus on biofuels. And when you go through any kind of mechanism to produce a biofuel, it will require at some point a concentration as you dehydrate that alcohol. And right now we use very expensive distillation towers. They are cumbersome, they take a lot of money to put together, and they are not really very efficient from the energy perspective. Vaperma and White Fox both have membrane systems for separating and dehydrating the water from the ethanol. So again, they're contributing to the efficacy of that technology. Quantium is an example of a less carbon-intensive and more efficient technology. It does work with the petrochemical industry. In fact, it's used in the olefin crackers, and it's a catalyst that coats the coils of those crackers and reduces the energy intensity by about 10% or so, which actually translates to a very large saving in the energy intensity of that production. Plasco is a perfect example of deriving economic value from a waste stream. We always like to look at a big change between bad and good, and anything that convert waste, in this case municipal solid waste, through a plasma technology that gasifies that waste to produce both energy and a little bit of deposit afterwards, and also you essentially are taking a revenue stream and taking this and making it a revenue stream. So it's a really exciting technology that will not meet some of the problems that you've seen with other MSW type treatments. Scheck Labs, it's all about hydrogen production in steam methane reformation, which is the standard way of making hydrogen. That's highly energy intensive. And Scheck has got a water splitting technology that's powered by solar and therefore will produce renewable hydrogen, which, as you can imagine, will certainly see a premium in the marketplace. So all of these are examples of clean technologies, and you can see that they're very wide-ranging. I want to just sort of talk about then the context of where we are around intellectual property, and not surprisingly in the figures for 2005 for renewable energy patents, you can see that the US and Japan lead the way. But Canada ranks there in number 8 position with about 4% of those. And so you can actually see on a per capita basis that Canadian universities and laboratories are doing a fantastic job of bringing forward great IP that obviously needs to be taken to market. If we take that same theme around policy opportunities and look at different regions, again, the top 10 creators of patents for renewable technology, you can see in here Ontario at 54, the San Jose, San Francisco, Oakland area is in the same league. So what you have are strong players, obviously, across the country in how we can contribute. Another thing about clean tech is that people weren't necessarily used to what it all meant, but also how big is the capacity in Canada. And I'm here to tell you that that capacity is massive. We have seen in 7 short years about 1,500 different applications representing nearly 4,500 different entities who are trying to develop and bring to market a clean technology. They've requested over $14 billion worth of funding. They haven't received it. However, there is a lot of, I would say, pent-up demand, and I'm quite sure that some of the people in the room today have that experience. And SDTC itself manages a portfolio of some 140-odd different technologies from 57 different technology groups that is valued currently at over $1 billion, which is one of the largest funds of its kind in the world. If you want to get some sense of the clusters of clean tech across this country, you can see that there is activity anywhere at all. So in British Columbia, we would classify some of their high areas of performance around the hydrogen economy, power electronics, tidal power, and actually in-river systems as well. Alberta, not surprisingly enough, looking at energy efficiency and improvements around the production of fossil fuels, but also in carbon capture and storage.